Stream ciphers are an alternative to block ciphers. RC4 is a good example of a stream cipher. This code has also been developed by Ron Rivest. If you configure the previous three modes in such a way that shifts a single bit, the result would be a stream cipher. Block size is 1 bit. The blocks are encrypted bit by bit using a long key. There are some ciphers that employ a mode of operation that is exactly like that. They are frequently used for transmissions. One of the most popular applications of RC4 was the point-to-point tunneling protocol, the method used in Microsoft implementations of virtual private networks. RC4 was developed in 1987, and its operating principle was disclosed in 1994. RC4 exhibits a striking similarity to the perfect one-time pad cipher. The difference is that you have to lengthen the key artificially. You have to spread out the key bits to make its length match the bits in the plaintext. Even though the algorithm itself has been tested and regarded as secure, implementing it can cause problems. All earlier versions of Microsoft Office are a good example of RC4 implementation problems. Another instance is the operating system SAM file. We talked about this before. You've probably noticed that if you're using Office 97 or Office 2003, you have the ability to encrypt Word, Excel, and PowerPoint files. The RC4 cipher was the default cipher used for this. There's a huge amount of tools for retrieving forgotten Office passwords on the internet. They are very affordable. Why is that? The basic problem RC4 has is that you shouldn't reuse the key to encrypt the same message. The XOR operation is performed there, but if a key is reused, an attacker can reverse the XOR and disclose some information on the plaintext and the keys as well. It's easy to see that if you encrypt the same data multiple times using RC4, if the key is the same, the ciphertext will be the same each time. Microsoft implementations use the same key every time. And now we'll briefly tell you about the operation. At first, a key stream has to be generated. Then, the key stream needs to be combined with the original plaintext using the XOR operation. After this process is completed, the result is very much like the one-time pad, except the key stream here has lesser entropy than that perfect cipher. To generate this cipher, you need a secret, an initial state. The initial state is usually generated by a permutation of the 256-state box and two 8-bit index pointers. Once a vector's, a key stream's, initial state is generated, it can be made longer to match the length of the plain text.